Hello, Infinity Explorers. Welcome to our very first video on this channel. Today, we will dive into one of the most fascinating and mysterious topics in the universe: the possibility of time travel through black holes. Imagine being able to travel not only through space but also through time. This concept, which seems straight out of a science fiction movie, might have real scientific foundations. But how could it be possible? And what would the implications be? First, let's talk about what black holes are. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. This happens because matter has been compressed into an extremely small space, creating an incredibly powerful gravitational field. Albert Einstein's theory of general relativity revolutionized our understanding of gravity and time. According to Einstein, space and time are intertwined in a single fabric called spacetime. Black holes warp spacetime in such an extreme way that they create extraordinary effects, such as time dilation. Segment with visual aids explaining black holes and general relativity. To better understand this, let's break it down further. Picture spacetime as a rubber sheet. When you place a heavy object on it, the sheet bends around the object. This is similar to how a planet or star warps the fabric of spacetime. A black hole, however, is like placing something infinitely heavy on the sheet, creating a bottomless pit. Now, let's discuss one of the most fascinating theories, that of wormholes, or Einstein-Rosen bridges. Imagine a sheet of paper. If you fold the sheet and make a hole on both sides, a wormhole would be like a tunnel connecting these two holes, allowing instant travel from one point to another. This concept has fascinated scientists and science fiction writers for decades. Segment with animations showing the concept of wormholes and space-time folding. But what does this mean for time travel? According to some theories of Einstein's general relativity, if one of these spatial tunnels existed and could be stabilized, it could theoretically allow travel not only through space but also through time. For example, one end of the wormhole could be accelerated to near-light speeds, creating a time difference between the two ends of the tunnel. This would mean that entering one end of the wormhole and exiting the other could theoretically allow traveling forward or backward in time. However, there are many obstacles to this theory. Stabilizing a wormhole would require a form of negative energy or exotic matter, which is currently purely theoretical. Additionally, the risks associated with entering a black hole are immense, as tidal forces near the event horizon could destroy anything that gets too close. Segment with expert interviews or quotes from physicists on the challenges of wormholes. But let's not stop there. Let's explore some additional concepts that might make this theory more understandable. For example, let's talk about time dilation. This effect has been confirmed by numerous experiments and observations. Near a black hole, time flows much more slowly compared to a distant observer. This means that if we could get close enough to a black hole without being destroyed, we could travel into the future. To better illustrate this, consider an astronaut orbiting a black hole. For the astronaut, time flows normally, but for a distant observer, the astronaut appears to move in slow motion. If the astronaut could return to Earth after orbiting near the black hole, they would find that many more years had passed on Earth compared to their clock. This effect is similar to what the characters experienced in the movie Interstellar. Segment with clips from Interstellar and discussion on time dilation effects. Let's also explore the concept of the event horizon, the boundary beyond which nothing can escape the black hole. This horizon represents a point of no return. However, some theories suggest that within the event horizon, there might be additional dimensions or parallel universes. These ideas come from string theory and quantum mechanics, fields that seek to unify gravity with the other fundamental forces of the universe. Segment with visuals explaining the event horizon and theories about what lies beyond. Finally, let's consider the philosophical and moral implications of time travel. If it were possible to travel into the past, could we alter significant historical events? And what would be the consequences of such actions? These dilemmas have been explored countless times in literature and cinema, but could one day become real issues for humanity. Segment discussing famous time travel stories in literature and film and their moral questions. Despite these obstacles, the possibility of time travel through black holes is an active and fascinating field of research. Scientists are continually exploring the implications of general relativity and quantum physics to discover if these extraordinary journeys could one day become reality. Closing segment summarizing key points and looking ahead to future discoveries. Thank you for exploring this incredible topic with me, Infinity Explorers. If you enjoyed this video, don't forget to like, subscribe to the channel, and hit the bell icon so you don't miss any of our cosmic journeys. Until the next adventure.